Good day, everyone. I'm Fernando, and I lead the cloud storage engineering organization at Atlassian. I am here today to share with you some of the learnings of operating OpenSearch at Atlassian scale. But first, let me tell you a bit more about how OpenSearch is used across Atlassian. OpenSearch is so flexible, it allows us to power many different scenarios. For example, we use OpenSearch for storing high-volume operational data and translating GraphQL to search queries to power our internal use cases. We also use OpenSearch for customer-facing scenarios like user search, user and team pickers, recommendations, and invites across all our products. Now, who here has used Jira? Well, thank you for being a customer. Searching for Jira issues used to be powered by PostgreSQL, but we recently shifted Jira query processing language to OpenSearch. And we have seen some significant scalability and performance gains, but it wasn't easy. Jira expects read after write consistency, as opposed to the eventual consistency model that we get with OpenSearch. Another show of hands, who here has used Rovo? Well, I hope by next year, I'll see a lot more hands now. Rovo pushes the boundaries of OpenSearch by leveraging semantic, lexical, and structured search capabilities. So please indulge me while I tell you a bit more about it. Rovo, Atlassian's AI-powered offering, enables all teams to harness AI's potential through tailored enterprise search, chat, out-of-the-box agents, and highly tailored agentic workflows. Powered by the Teamwork Graph, Rovo delivers relevant answers and detailed insights driven by your team's knowledge. But what exactly is the Teamwork Graph? Well, when you think about two people or two teams collaborating together, what enables strong partnership? Understanding, alignment, and ultimately, a relationship. Now, for the teamwork involved in being a tech company, those relationships are between the teams, the goals those teams are going after, the work they commit to, and the knowledge they share to get that work done. The Teamwork Graph, powered by OpenSearch, anchors those core nouns to build a common data model to enable teamwork and ensure that Rovo is able to give the best contextualized responses to the problems that an organization is trying to solve. Rovo Search helps you find what matters across all your apps. With 50 connectors, Rovo centralizes knowledge across all your SaaS apps. Search can be accessed on browser extensions, including Chrome, Edge, and other Chromium-supported browsers. And I know what you're thinking, but I don't have any more information about Arc or Dia at this point. What I can tell you, though, is that search results for users only show what they have permissions to. Smart Answers also give you AI-generated answers that are personalized based on your experience. And you can also search by ad mentions, social signals, search summaries, and major relevance investments. Now, Rovo is available for all teams in Atlassian's cloud. And at our scale, things get complicated. So let me share some numbers to put Atlassian scale into perspective. 300,000 customers, 2 million monthly AI users, over 13 regions worldwide, plus our government and isolated clouds, and as we recently announced, a new cloud provider coming soon. How do these numbers translate to OpenSearch infrastructure? Well, we run over more than 300 clusters, over 2,000 data nodes, and a few of our largest clusters hold over 20 billion user-generated documents. At our scale, we see some significant challenges. Multi-tenancy allows us to run cloud services efficiently. Unfortunately, at our scale, this is not easy on OpenSearch. Shared information is kept in memory in every node, which limits the number of indexes we can store in a single cluster. We try to minimize the number of clusters in our fleet, so we use a single index and custom routing to map between tenants and shards. This adds complexity. Once results are retrieved from an index, we perform tenant-level filtering, which adds latency and degrades recall. Another challenge is the AWS OpenSearch service only exposes cluster and node-level metrics, but we need shard metrics to get customer-level visibility. This limits our ability to optimize the service. Earlier in my career, I had a manager who would always say, challenges are opportunities. And frankly, that was a bit annoying, but if I'm honest, it was a great advice. So let me tell you a bit more about how we've tackled some of these opportunities. At our scale, managing individual clusters is not feasible. We built a control plane to manage fleets of clusters and provide baseline security and compliance across all our infrastructure. We also built tooling to manage our indexes, to safely roll out changes and ensure consistency across our multiple environments. We invested in observability and change management capabilities to drive standardization within the fleet. Avoiding infrastructure differentiation is essential to scaling efficiently and reducing complexity. Our control plane also handles enterprise data flows like customer-managed encryption keys and data residency guarantees. But scaling has also required significant cultural changes. Historically, at Atlassian, we have worked on a you build it, you run it philosophy, where each team is responsible for the operational aspects of the services that they build. This approach has resulted in empowered, autonomous, and agile teams. However, there are drawbacks to this approach, such as duplication of effort and inconsistencies across services. These drawbacks conflicted with our expanded ambitions in the enterprise market. So we shifted towards centralized infrastructure and expanded governance controls to meet our customers' security, reliability, and compliance needs. And we still operate on a you build it, you run it model for our services, but when it comes with infrastructure, we prefer centralization. And we have adopted many more company-wide technology standards to drive that consistency. But there's more. Our space is evolving and growing rapidly, and we need to keep up. Our AI MAU grew over 50% since last quarter. This is a great problem to have. But as demand grows, building and configuring new clusters can become a time-consuming and expensive operation. We need to constantly balance new feature deliveries with operating the live service and paying off technical debt. AI presents a unique opportunity. We shipped Rovo in just 6 months, and we keep moving fast and iterating to deliver more value. But sometimes we slow down because of things within our control, things like tech debt, platform gaps, or bugs. Other times, there are things we can't control, like being on a managed service means that we are subject to someone else's schedule and priorities. And sometimes we end up waiting longer than we'd like for features and bug fixes. Finally, being a platform team with multiple customers, we end up having to support multiple versions, topologies, and configuration settings. This significantly increases our complexity matrix. We also have to keep up with the rapidly evolving OpenSearch landscape. There have been so many new features recently released, and our customers want them now. When we looked at these challenges, our scale, and our multi-cloud strategy, we knew we had to build our own OpenSearch platform. And lucky for us, this community has built some really powerful and robust software, and we're able to stand on the shoulders of giants. We chose Kubernetes to orchestrate our clusters so we could leverage the rich ecosystem and the tooling. We use Cargo and Argo CD for progressive rollouts and Carpenter for node management. For observability, we use Prometheus and OpenTelemetry. It's been just a year since we got started, and I'm delighted to share with you that all your Jira search queries are now powered by our platform. So it's been very fast-paced 12 months, and we have learned so much, so let me try to share some of those learnings. It's probably obvious for some of you, but running stateful services on Kubernetes is not straightforward. Our pods come and go, our nodes are periodically restarted for security patching, and we have little to no control over these things. We designed our system to leverage availability zones for resilience, but that wasn't enough. We dove deep into stateful sets and to fine-tune how the system deals with failures. For instance, we get much faster provisioning and recovery times by pre-creating volumes in the desired AZs instead of relying on stateful sets. Reaching over 4 nines availability was hard. There are lots of knobs and so much complexity around shards, indexes, and segments that simple tweaks can have significant impact on cluster reliability. At steady state, the control plane is fairly robust, but poorly orchestrated deployments or failures can overwhelm a cluster, saturate the network, and bring it down. It is extremely important to understand the limits of a cluster and not exceed them. And automation is essential at our scale. Finally, it is critical to have the right observability. Monitoring too many signals can bring the cluster down, but not monitoring enough can make troubleshooting almost impossible. We collect node level metrics every minute. Cluster and index level metrics require communication across nodes. So we use outside collectors at intervals of 5 minutes. We've also had good success in reducing time to resolve incidents through activity correlation and have prevented some incidents through a recommendations engine. We've been able to move quite fast because of the great community support. The tooling and learning resources are awesome. We are grateful for your contributions and are eager to give back. Operating OpenSearch at Atlassian scale requires some serious innovation. We manage hundreds of clusters, thousands of nodes, billions of documents, and the demand for search keeps growing at an accelerated pace thanks to AI. And we do this all while maintaining 4 nines availability, low latency, and enterprise-grade security. Out-of-the-box tooling is a great starting point, but at our scale, we need tailored solutions. We built our own platform to optimize for our use cases and enable our multi-cloud strategy. Our team moves fast, bringing new features to the platform with every sprint. We are the flywheel that powers innovation for our products and AI. And we do all of this while having fun. Developer joy is fundamental to how we build software. We invest in our culture, in empowering our teams, and in awesome tooling. One of the most compelling examples of Atlassian's AI innovation is our use of RoboDev, our AI-powered developer assistant. RoboDev has allowed us to streamline our pull request process, reducing PR cycle time by 45%. This means our teams can iterate, merge code significantly faster, accelerating the pace of innovation and delivery for our customers. RoboDev uses AI to accelerate code reviews, suggest improvements, and surface potential issues early in the development cycle. This not only boosts efficiency and enhances code quality, but also brings developer joy. Operating OpenSearch at Atlassian scale is impossible alone. We are excited to be part of this community, to share our learnings and tackle common problems together and unleash the potential of every team. Our journey is only starting. There are plenty of opportunities ahead of us. I hope you enjoyed this talk. We will be available at the Atlassian booth after this in case you'd like to say hello or have any questions regarding my talk. Thank you.